Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever manage to stay on top of the food chain. Animal super senses. You won't believe what's possible. Hello, and welcome to another installment of Animal Super Senses, the show where animal instincts and perception are the stars. In this episode, we examine how every animal has what could be called the sense of rhythm, the human animal included. To give an obvious example, there's our internal body clock that responds to circadian rhythm. That's the 24-hour day and night cycle. Circadian rhythms are synchronized with what is known as photoperiod. In simple terms, the length of a day. Changes in the amount of available light are detected by mammals in a tiny area of the brain called the SCN. It's like a master clock which responds to the environmental cycle. Some animals, of course, are diurnal, mostly active during the day, while others are nocturnal. They sleep through the day and are busiest after the sun goes down. But there are other rhythms with a longer cycle, often in tune and affected by the seasons. For example, biologists recently identified a photoreceptor cell deep inside the brains of birds, which responds to daylight and nightlight, but also regulates breeding activity according to seasonal changes. Animals synchronize their body clocks for biological purposes, such as reproduction, hibernation, fur color changes, and migration. But exactly what senses are at work to help animals keep in tune with the rhythms of day and night and the changing seasons? The answers coming up in this episode may just surprise you. Did you know that all vertebrate animals, which of course includes human beings, have a special organ, the pineal gland, also known as the third eye, which detects daily changes in the amount of light? In human beings, the pineal gland is located in the center of the brain. But in birds, reptiles, and fish, it is located on the forehead, just underneath the skin. For workaday diurnal animals, the light-sensitive pineal gland releases more melatonin during the night than by day. This helps animals set their body clocks, letting them know when to be active and when to go to sleep. As mentioned, humans have a pineal gland, and this so-called third eye has long been attributed with mystical powers since ancient times. Whatever its spiritual properties, the pineal gland seems to help animals adhere to a 24-hour rhythm and regulate their sleeping and waking cycles. Some lizards, frogs, lampreys, and species of fish literally do have a third eye, known as the parietal eye. The tuatara is a reptilian survivor of the dinosaur age and is found only in New Zealand. In mammals, the pineal gland is buried deeper inside the forehead, meaning that it cannot receive light directly. So how does it sense changes between day and night? Recent research has found that the pineal gland is directly linked to the retina in eyes. In diurnal mammals, and again it includes us, the melatonin hormone makes us sleepy. Scientists have recently shown that in nocturnal animals, the pineal gland still secretes melatonin, even during darkness, during the period when night creatures become the most active. So clearly, melatonin is not the universal sleeping pill. In some species, it may have the opposite effect. Incidentally, do you know how much sleep the average adult requires? That's right, only 5 more minutes. Excuse the levity. Of course, the whole cycle of life is in so many ways dependent on timing. The changing seasons has an impact on reproductive cycles in many species. Animals like these Rocky Mountain bighorn sheep, found in high places from British Columbia to Arizona, live their entire lives in sync with the changing of the seasons. Changes in temperature and the lengthening or shortening of days, these are keenly felt at high altitudes. The timing of the mating season becomes vitally important in harsh climates. Mating occurs at a particular time so that the young may be born when the weather is at its mildest and resources are most abundant. Staying in Arizona, where these pronghorn antelope are most definitely seasonal breeders. Mating season begins with a head-butting contest between males, as they compete for mating rights and access to females. Bucks separate from others in August and begin hanging around with the does. Male pronghorns grunt and snort, pushing and fighting the other bucks to gain the attention of females. They rub their antlers on trees and bushes, marking areas with their scent. It's an impressive display, but it won't be totally unfamiliar to anyone who watches so-called reality television dating shows. This sense of timing is found throughout the animal realm in such phenomenon as hibernation, fur color changes, or migration. We'll take a look at all of these in due course, but first up, let's see if we can both get our lips and your heads around a state of suspended development called embryonic diapause. It's just what it sounds like. Embryonic diapause, that is. The embryo takes a pause, meaning the embryo does not immediately implant in the uterus, but is maintained in the state of dormancy. By far, the most famous case of this state of arrested development takes place in the outbacks of Australia. This is a reproductive strategy, so kangaroo moms can time the birth of their young in order to avoid going into labor during unfavorable environmental conditions, such as droughts. When the time is right, the embryo is reactivated. The little joey kangaroo is born and then crawls into its mother's pouch. This phenomenon occurs in a number of marsupial species, but is especially prevalent among kangaroos and wallabies. This is also known as delayed implantation. It's something common to rodents, bears, weasels, and badgers too. The arrested development of a joey almost pales in comparison with how some animals are able to shut down everything but vital signs during that state of suspended animation we know as hibernation. And the world's super hibernator is undoubtedly this fearsome-looking predator, the black bear. Also known as the American black bear, though they can be found in large numbers across the border in Canada as well. American or Canadian, it doesn't matter. In any case, the black bear hibernates 5 to 7 months of the year, during which time it does not eat, drink, urinate, or defecate. During this period, they completely throw all their other circadian rhythms out the window. As they move from summer to autumn, black bears, and indeed bears in general, begin feeding even more than usual. Males and females will gorge themselves on an average of 30,000 calories a day. We don't advise that you try this at home. This conspicuous consumption is all for a reason. It creates a layer of fat which will act as insulation and kind of a metabolic reservoir for their time in super hibernation. Now, chipmunks are of course hibernators too, so let's compare what they get up to with the habits of the black bear. When the chipmunk goes into a deep sleep, its body temperature can drop by more than 6.6 degrees Celsius. The upshot is that the chipmunk must wake up every few days and feed like nobody's business. The metabolism of a black bear, on the other paw, will slow to where they are taking just 1 or 2 breaths per minute, and their hearts beat 8 to 12 times per minute. But this is not a competition. And there's no doubt that many small mammals, such as chipmunks but also woodchucks and ground squirrels, are some world-class hibernators. The hibernation habits of the Arctic ground squirrel are surely worthy of note. A year-round resident of the Arctic tundra, this ground squirrel has a hibernation period of up to 7 to 8 months. During its deep sleep, the Arctic ground squirrel's core body temperature drops just below freezing. Once every 2 to 3 weeks or so, it shivers and shakes without waking for more than a dozen hours at a time to reheat its body. Another way in which animals have the sense to register changes in seasons is by changing into their winter wardrobes. The Arctic fox is a classic case in point. Life can be difficult for this elegant-looking little creature, but the Arctic fox makes the best of its lot, preying on whatever creatures it can find for survival, including lemons and voles, and perhaps, to make life on the tundra a little less solitary of a journey, the Arctic fox is a monogamous creature and mates for life. They're also relatively involved parents, with mother and father helping to raise the average of 5 to 8 cubs. Be that as it may, let's get back to the Arctic fox's fashion sense. During the short Arctic summer, its fur is a brown color. As winter sets in, the fur thickens and turns white, thicker for obvious reasons. White so that the creature's camouflage matches the season, and that of course means white as snow. Animals' body clocks can last longer than a day, or a season, or even a whole year. To illustrate, we leave the frozen tundra of the Arctic behind and travel to the deciduous forests of the eastern United States, the principal habitat of the periodical cicadas, also known as magicicadas. Cicadas spend a lot of time underground. In fact, the vast majority of their lives. For a period of either 13 or 17 years, both prime numbers you will note, cicadas stay underfoot, feeding on the roots of deciduous trees, and yet, slowly, ever so slowly over this time, they develop and mature. Then, finally, for a bit of few glorious weeks, when the almost adult cicadas are at the so-called nymph stage, they emerge from the ground in large numbers. They shed their skins one last time, and after a few days, their exoskeletons harden completely. Then they take to the skies, singing the familiar cicada mating call to find a mate. The question is, after every 13 or 17 years, how do they know when to come out in such precise intervals? Recent research thinks they may be keeping track of the sap cycles in trees, but still, no one knows for sure. One thing we haven't really touched on in our examination of animal timing is the effect of the moon on animals. For the lunar cycle governs the timing of natural events as much as the sun. A long way from cicadas, at the edge of the ocean in this case, the coral reefs around the Gold Coast of Australia. We can see clearly how life is affected by the lunar cycle, especially in underwater life. For just 1 week of every year, in spring, after a full moon, millions of corals will release their eggs and sperm in a symphony of reproductive activity. This spectacular example of group sex, which is what it is if you think about it, has long been a source of fascination. But up until less than a decade ago, it was a mystery how these seemingly primitive beings, which somehow get through life without brains or eyes, synchronize their annual mass spawning. But in 2007, scientists were able to isolate an ancient gene in the corals which is capable of detecting moonlight. On Animal Supersenses, every episode serves to demonstrate that while we like to think of ourselves at the top of the food chain, when we look at our senses, compared to the phenomenal abilities of other animals, we are just fumbling in the dark with earmuffs on. See you next time on Animal Supersenses. Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever managed to stay on top of the food chain. Animal Supersenses. You won't believe what's possible. Welcome to Animal Supersenses, the show that plugs you in to how animals experience the world, often with sharper and more evolved senses than the one species who likes to think of itself as the top of the food chain. That would be us, of course. While all life began in the oceans, human beings now rely on technology to navigate the seven seas, left to our own devices. We're like the proverbial fish out of water, only the other way around. Once underwater, with light diminished, our vision becomes blurred, our hearing becomes muffled and distorted, and our sense of smell is rendered completely useless. Now compare that, for example, to that renowned predator, the great white shark. This elegant killing machine is perfectly attuned to every sight, sound, scent, chemical, and electrical signal of its marine environment. We'll pay a slightly nervous visit to the great white a little later in the episode. But first, listening carefully? Because the sense of hearing enters a whole nother dimension when applied to creatures of the deep. Hearing is critical for animals such as the sperm or humpback whale. For one thing, light fractures and weakens underwater, so vision becomes a less important tool for survival. Sound, however, travels further in the water than in the air. So for whales, it's critically important as a way of communicating, most famously as in the song of the humpback whale. Humpback whales are members of the cetacean family, which includes whales, dolphins, and porpoises, all of which have well-developed senses of hearing. In the case of this humpback whale, its outer ear is a very small opening that closes once underwater. Instead, It picks up on waterborne vibrations through bones in its head, good vibrations that ultimately reach its middle and inner ears. Fascinatingly, the ancestors of the whale actually walked on land. Pakistanidae, or Pakistani whales, lived on the shores of the Indian subcontinent and began to diversify, making for the water some 53 million years ago, give or take. More about them and their ancestors later in the show. Meanwhile, to be a little bit more specific about what hearing is, it's the ability to sense sonic vibrations. Sound and what is known as vibrational stimuli, they pretty much amount to the same thing underwater. The scene now is the Coral Triangle. This is the area of tropical marine waters around Malaysia, the Philippines, Indonesia, and East Timor. A tropical paradise in many regards, sometimes known as the Amazon of the seas. But one that the World Wildlife Foundation is keeping a close eye on to ensure human activity doesn't spoil this particular paradise too. Among the countless species that call the Coral Triangle home, you'll find plenty of cephalopods. Plenty of what? Cephalopods, like cuttlefish and this octopus, are invertebrate, spineless mollusks with generally large heads and symmetrical bodies. For over a century, there's been a debate as to whether these creatures are capable of hearing. But the consensus seems now to be that they can, either by something called the statocyst organ, a fluid-filled sac lined with sensory hairs that also helps them to maintain balance, or they can hear via lateral lines, similar to that found in fish, visible lines on the fish's body comprised of sense organs which detect pressures and vibrations. Now, of course, there are more fish than you can shake a million fish sticks at in the Coral Triangle, and chances are they'd hear you when you shook those sticks at them. Because as any goldfish owner can tell you, at any kind of threatening sound, a fish will curl into a tight C shape and head in the opposite direction. So whether in a goldfish bowl or the Coral Triangle, we know that fish can hear, but believe it or not, scientists are somewhat divided as to how. Here are the two main theories. The bodies of fish have about the same density as water, which means that sound passes through their bodies. But fish have bones in their inner ear, which are called otoliths. These bones are denser than both the water and the fish's body. This means these bones move at a slower pace than the rest of the fish's body, and also the speed of the sound waves. The upshot of this is that the difference in speed between the otolith bones and the rest of the fish's body ruffles the hairy sensor cells located in its inner ear, This differential movement is interrupted by the brain as sound. Then there are the lateral lines we mentioned before. These are essentially a set of tubes located just under the fish's, or in this case, the shark's body. Water enters these tubes through the pores of the skin. The tubes are lined with hair cells, which are connected in turn to sensory nerves. When anything gets close to a shark, the water running through the lateral lines moves to and fro. This stimulates the sensory cells, which alerts the animal to whatever prey or predators may be in the vicinity. When we talk about animal supersenses, perhaps no animal fits the bill more than the shark. In the popular imagination, we imagine them, like this blacktip shark, moving stealthily through the water and then seizing their prey without mercy, relentless and unstoppable. And that's about the size of it. Their senses are also supremely well adjusted to make them effective underwater predators. For one thing, they have a particularly acute sense of smell. Unlike, for example, human beings, sharks have separate and distinct openings for breathing and for smelling. The gills on the side of their heads are for breathing only and serve to capture oxygen in the water. Meanwhile, two nostrils to the front of their heads pull water into a nasal chamber specifically dedicated to detecting smells. Perhaps one reason a shark's nose works so well is because it doesn't have to do anything else. Breathing is accomplished with their gills, and a shark's sense of smell is not in any way connected to its mouth. But a shark's sensory arsenal doesn't end there. Sharks come with a unique sense organ as standard equipment, something called the ampullae of Lorenzini. They were first described back in the 17th century by one Stefano Lorenzini. They consist of small clusters of electrically sensitive receptor cells found just under the skin. These are connected to the water by pores on the shark's snout and head. What the ampullae of Lorenzini do for the shark is to outfit it with electroreception. In a nutshell, electroreception means the shark can sense the bioelectric fields generated by other animals and use it to locate them. And hey, you'd expect the ultimate predator to know where its next meal is coming from, right? Blacktip sharks like these share the waters of the Coral Triangle with a cetacean known for its hearty appetite, the sperm whale. And also with the sperm whale's distant cousin, the dolphin, a marine mammal who is no slouch in the appetite department either. They may be enthusiastic eaters, but they don't exactly enjoy their food in any way we might understand. You see, just about all vertebrates enjoy 5 primary tastes: sweet, salty, sour, bitter, and umami, except that is for cetaceans such as dolphins and whales. New research has revealed at some point in their evolutionary journey, they lost the ability to perceive anything but salt. Scientists believe this took place between 53 million years ago, at the point when whale ancestors, Pachycetidae, took to the seas, and 36 million years ago, when they split into two groups, toothed and baleen whales. Then again, if you swallow your food instead of chewing it, perhaps not having a sense of taste isn't such a great loss. What about underwater vision? All you need to do is hold your head underwater for a few seconds, and you'll see that our eyes are not adapted for vision underwater. No, they've evolved for viewing in air. Everything is a blur underwater, right? That's because light rays bend when they travel from one medium to another, from air to water. Water refracts light at roughly the same degree as the cornea of the human eye, which effectively eliminates our ability to focus. Fish eyes are more spherical in shape, allowing them to focus under the waves. In many cases, they're also sensitive to a larger range of the color spectrum, including ultraviolet light. As light passes through deeper and deeper waters, more color is absorbed and diluted. The water filters out the color red at first, then yellow, then green, and then violet. The color blue is the last to go. And yet, as recent studies show, ultraviolet light penetrates far deeper into the water than used to be thought. Could this be the reason why so many fish are so very colorful? That while their colors might, to the human eye, be muted by the ocean depths, to a fish with ultraviolet sight, these creatures still stand out as bright and beautiful. The answer appears to be yes. In some cases, many coral reef fish, for example, are brightly hued, coming in a dazzling array of colors. The harlequin tuskfish, mandarin fish, coral trout, regal angelfish, and stoplight parrotfish all spring to mind. Scientists believe that some fish use their brightly colored skins to attract a mate. But, as with so much in nature, it's more complicated than that. For color is also employed by some fish as a warning system, a warning to back off and stay away. Lionfish, for example, are thought to utilize their brightly colored bodies to communicate to other animals that it's best to stay away from them, and more especially, their highly venomous spines. Then again, there are instances when fish like to blend in with their surroundings. Literally, it's called cryptic coloring, and it enables some species of fish to camouflage themselves. A predator, like the great white shark, might seem like the last customer who would need to hide itself away. But the great white, along with many other open sea fish, uses counter shading to camouflage itself on a regular basis. But one of the strangest and most effective underwater senses is known as echolocation. This is very much what it sounds like in a way, being able to locate something because of its echo. It's also known as sonar, which humans have studied and replicated, for example, for use in submarines and naval warfare. This is a system for detecting objects underwater by emitting a sound pulse. And then being able to detect and measure it upon its return to find out where something is, its size, and so on. call it seeing with sound, because in effect, that's what it is. Dolphins use echolocation all the time. Like all toothed whales, dolphins have specialized fat located in their jaws which convey sound waves from the ocean to their ears. They use echolocation to crater feed, meaning to find prey underneath the sand, because unlike other senses, echolocation can penetrate or see through solid matter. It's a primary sense for dolphins and other species of toothed whales. That's right, a dolphin is also a type of whale, a type of toothed whale, to be precise. Other varieties of toothed whales include sperm whales, killer whales, and beaked whales. All of these creatures use sonar, or echolocation, to guide them through the oceans, to communicate, and to detect prey. As you'll recall, the distant, 50 million years plus distant ancestors of whales were actually land-dwelling mammals, who probably saw things quite well in the open air. Echolocation helped them adapt to life underwater. Navigating the open ocean, with its shifty currents and expansive water, for most animals is no easy feat. But sea turtles have to face up to the challenge. There are 7 species of sea turtles found in the oceans all around the world. They spend their first few years floating in the open sea, where they feast on jellyfish and other creatures. But at some point, they need to find their way to the beach to breed. And it's not just any beach. They return to the one they were born on. How they actually do this is still being debated, but it's thought they may use the Earth's magnetic field as a cue, and perhaps their sense of smell plays a role as well. On this stretch of South American shoreline, an olive ridley turtle clambers slowly up the beach. This female adult is about to lay a clutch of eggs. Over 100 eggs can be deposited in a nest at any one time. Once the eggs are buried, the adult returns to the water. After incubating for over 45 days, hatchlings emerge to begin a perilous journey. They race to the water's edge. But vultures with a taste for turtle are patrolling. And even when they reach the sea, it's still not safe. Few hatchlings make it to the feeding grounds in the open ocean. It could be why the olive ridleys have a remarkable nesting strategy. In a spectacular mass nesting get-together known as an arrebada, thousands of females come ashore simultaneously to lay eggs. How the females know the time is right is unknown. They may release a scent that cues the start, but with no conclusive answer, the arrebada continues to be one of nature's great secrets. On Animal Super Senses, we've taken you from the surface to the depths of the 7 seas to seek out the treasures below. From the tiny, colorful fish of the coral reef to the mighty sperm whale, we've explored how these creatures hear the vast beauty of the ocean world. It could make you wonder why our ancestors ever came out of the water in the first place. Just be sure, we'll come to our senses again next time on Animal Super Senses.
Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever managed to stay on top of the food chain. Animal super senses. You won't believe what's possible.
Animals that live life on the wing have a vast expanse of sky to navigate, find mates, locate food, and avoid predators in. Living in this aerial realm requires a unique set of senses, specialized to cope with life above ground. In this episode of Super Senses, we find out more about when senses take flight and animals become masters of the sky. The speed and precision of a bird of prey captures our attention and leaves us awestruck. From a soaring height, they scan the ground for a pigeon-sized meal. Open grassland is perfect territory. To cope with searching a vast area, they need super sharp sight. The peregrine falcon, like most predators, has forward-facing eyes. Binocular vision helps in depth perception, essential to spot fast-moving food. Their eyes rely on several visual enhancements. Each eye has two fovea, dense areas of photoreceptors. Most animals only have one, but the peregrine falcon has a deep and shallow fovea. These clusters of light-sensitive nerve cells provide acute vision for viewing distant objects. Their favorite prey are medium-sized birds. They mark their target from a height of 1,500 meters. With a power stoop reaching speeds of over 300 kilometers per hour, such acceleration would cause eyes to dry out as wind evaporates the tear film. But a nictitating membrane, or third eyelid, clears the eye of debris, and a specialized gland at the base of the membrane secretes a solution that moistens the cornea and protects the eye during the breathtaking stoop. As an aerial sniper, the peregrine falcon is a sight to behold. When a meal is spotted, the predator stoops, with wings folded close to the body. It's the perfect shape for dive bombing. It strikes the pigeon with its talons, stunning it on impact, then turns to catch it in midair. If the prey is too heavy, the peregrine will drop to the ground, where it settles to pluck the feathers before feeding. With such formidable vision, the falcon's prey stands little chance of escape. The falcon's sharp vision is impressive, but there is another bird of prey that can beat it. The wedge-tailed eagle also has two fovea in each eye, but it has the advantage of size. It's Australia's largest bird of prey. The wedgie, as it's known, has the keenest vision of any animal, and their eyes, relative to body size, are huge. A 4.5 kilogram eagle may have eyes as big as a 90 kilogram human. Sporting a 2-meter-long wingspan, this raptor truly is Lord of the Skies. It takes flight with slow, deep wing beats, and once aloft, skillfully uses updrafts of thermals to reach heights of 2,000 meters. Such powerful wings are put to good use, as it hunts by soaring above the open country, looking for rabbits and wallabies. Once spotted, it dives down at speeds of more than 80 kilometers per hour, grabbing its unsuspecting prey with its formidable 7-centimeter-long talons. Big, beautiful, and predatory, birds of prey get our attention, yet they share the sky with a much smaller winged hunter that could teach the raptors a lesson or two. Dragonflies, ancient aerial killers that seem dainty and ethereal, but don't be fooled by their delicate looks. New research suggests that the dragonfly may well be the most brutal and effective predators in the animal kingdom. With military precision and fighter pilot control, they rarely miss their insect prey, managing to snatch their targets in midair more than 95% of the time. They don't even stop to finish one meal, stuffing their mouths full of meat while moving on to catch the next victim. They can fly backwards, change direction in midair, and hover for up to 1 minute. What makes the dragonfly such an effective hunter? Dragonflies have multifaceted or compound eyes and, along with bees, have the largest eyes of any insect. The dragonfly sees the world in a mosaic. They have more light-sensitive proteins, called opsins, and this allows them to see colors that are beyond human visual capabilities, such as ultraviolet light. But that's not all. The light-sensitive proteins are segregated in the compound eye, with the upward-facing part only having blue and UV receptors. It's thought it gives a special advantage to hunting dragonflies, as the sky appears to be very bright, providing a clear background against which their small, moving prey can be more easily detected. Another advantage of having a multifaceted eye is the dragonfly's acute sensitivity to movement. Their super-sense eyes make the dragonfly the stone-cold serial killer of the skies. Each autumn, millions of monarch butterflies fly about 3,000 kilometers from the eastern United States to central and southern Mexico to spend the winter. The monarch's migration is one of the most spectacular sights in nature. Past research has shown the winged travelers navigate using the sun, but the question remained, how do they manage to stay on course during cloudy days? The answer lay, once again, in the ultraviolet realm of the sky. This time, the UV light wasn't providing the direction, but acted as a switch to trigger a magnetic compass located in the butterfly's antennae. Researchers have found that light-sensitive molecules in the antennae are turned on by ultraviolet light, the wavelength that peaks during summer. Because UV light can penetrate clouds and reach the butterfly's receptors, even on overcast days, their inbuilt GPS can kick in. This magnetic compass may serve as a backup navigation system to keep the butterflies on track when they can't see the sun. So we have super senses, like ultraviolet and polarized light, that help airborne animals find food and navigate their way. They are all about what can be seen of the wide blue sky that animals can use. But what about the other senses? The sense of smell responds to airborne chemicals, but in the expanse of sky, are the molecules too dispersed? Modern birds are known more for their flying abilities and their sense of vision and balance than for their sense of smell. But some bird species still rely on smell to search for food or navigate over large areas. And recent research suggests that they may have inherited this from the dinosaurs. New World vultures, like the black vulture, live in the warm and temperate areas of the Americas. It is a typical scavenger, feeding on dead and decaying flesh. And it soars high above the ground, looking for its next meal. But it doesn't have a particularly sensitive nose. Instead, this clever bird keeps a keen eye on the activities of its New World cousin, the turkey vulture. Turkey vultures can be seen circling effortlessly high in the sky. They are easily recognized by their red, featherless heads. But the turkey vulture's real claim to fame is as one of the few birds in the world that have a super sense of smell. Experts estimate that they can detect the scent of rotting flesh in concentrations as tiny as a few parts per billion in the air, and are able to sniff out a dead critter more than a mile away. While gliding in the sky, they track plumes of foul, sulfurous odors from decaying animals, and home in on it by flying in circles. Watching closely is the black vulture, lacking in the sense of smell department, but smart enough to watch the turkey vultures find the food, and then follow when the time is right. Birds and insects are renowned for their aerial ability, but mammals have only one representative capable of powered flight, and that's the bat. Like other animals, their senses are adapted to deal with life above ground. The saying, "being blind as a bat," simply isn't true. The bat world is made up of microbats and megabats. Microbats hunt for insects at night using echolocation, and yes, their eyes are small. But the bigger megabats have larger eyes. They don't echolocate, but forage at night for nectar and fruit, which they find with their acute sense of sight and smell. The forward-facing eyes of flying foxes are adapted for searching for light-colored fruit and flowers at night. Flying foxes see well during the day, too. Their daytime roosts are in large open treetops, very visible to passing predators. Having excellent eyesight means they can keep a lookout for enemies. The sense of smell also plays an important part in finding food for fruit bats. They sniff out the ripest fruit with the strongest odor, and cluster figs are a favorite. Flying foxes are very good climbers. Using their wrists and thumb claw to grip, they crawl across branches to forage. Their teeth are adapted to their diet, with canines that pierce and flattened molars to crush the fruit. But flying foxes don't eat the fruit whole. The tongue is used to press the pulp against the hard ridges of the palate to extract all the juice, which is swallowed, and then the fibrous part is spat out. The tongue is lined with small projections called papillae and covered with taste buds. Flying fox tongues are so specialized, with different types of papillae and taste buds reflecting feeding behavior, that each species can be identified by tongue morphology alone. Smell also plays a role in social interactions. Secretions from the bat's shoulder glands are spread over the body while grooming, and smell is used to recognize each other. Males rub their scent onto tree branches in the colony to mark a territory and to attract passing females. With their acute senses of sight and smell, fruit bats are able to live a sky-high life. In the desert of Australia's interior, thousands of pelicans seem to miraculously appear at a vast saltwater lake. It is a wonder of the Australian outback. Most of the time, the lake is bone dry and has little to sustain life. It's the last place you would think to find a water bird. But every decade or so, floodwaters turn it into an inland sea, teeming with microscopic animals that feed fish. And the fish-eating pelicans follow. It's here the lakes support 10,000 pelicans breeding a new generation. But these nomads of the sky have traveled across the vast interior to reach the fish-filled waters from the coast. How do thousands of pelicans know when to fly hundreds of kilometers to inland waters? What cues are they detecting? bird talk, inbuilt magnetic compasses, and the ability to hear vibrations from long distances are just three theories which try to explain why the birds migrate when they do, but there's no evidence. Experts think the birds may be using riverbeds as route maps, but that doesn't explain what triggers the flight. So the mystery of the Lake Erie pelicans continues to baffle scientists. The senses are the stars of animal supersenses, and this episode has been no exception. We've discovered animals use a range of senses to cope with life in the clouds. Given the distance and vast openness of the skies, animals make the most of what the aerial realm has to offer, and human abilities pale in comparison. So join us next time on Super Senses to find out more incredible powers of animal perception.
Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever managed to stay on top of the food chain. Animal super senses. You won't believe what's possible.
When the sun sets, the animal kingdom swaps shifts. Day workers go to sleep, while others get active. This is the night shift. And nocturnal animals have taken to this dark world for good reason. They escape from predators, avoid the heat of the day, and take their turn sharing food and resources in their niche. But to navigate life in the dark, you need some special abilities to cope with the lack of light. In this episode of Animal Super Senses, we find out more about the animals that live in the shadows and the adaptations they need to survive. Eyes rely on light, so it may come as a surprise to learn that some nocturnal animals depend on a great deal of their sense of sight to operate in the darkness. Having large eyes helps to compensate for low light levels. The ring-tailed possum is an Australian marsupial that spends the night feeding on leaves, flowers, and buds. They live life in the trees. An agile climber with claws on the hands and feet, including thumbs that help it to leap from branch to branch. and a strong prehensile tail that acts like a fifth limb. With large eyes, the possum has superb night vision. Although not a predator, the eyes face forward, providing binocular vision and depth perception, useful for judging distances when jumping through the trees. Gliders are a type of possum, and like the ring-tailed, they are forest dwellers. But instead of climbing from tree to tree, these possums do as their name suggests, glide. A thin membrane attached between their ankle and wrist helps them to fly. Sugar gliders gnaw through the bark of eucalyptus and acacia trees to get the sap and gum underneath. In spring and summer, they boost their diet with insects. To search for food, they fling themselves from one trunk to the next in the pitch black. So it helps a great deal for gliders to have excellent night vision. They are outfitted with huge, bulging eyes. But that's not all. Experts think their widely spaced eyes allow them to triangulate distance and prepare them for gliding to the next food source. But the prize for the biggest eyes goes to a strange-looking creature that lives beyond Australia's northern boundaries. Tarsiers are tiny primates found in the jungles of Southeast Asia. Their eyes are so large that one eyeball is bigger than its brain. Foraging at night, large eyes help the retina to collect more light. Gremlin-like and entirely carnivorous, they eat a variety of insects, pouncing on them using powerful hind legs from their treetop perches. Long, spindly fingers help them cling to trees and can be used as a kind of cage to trap prey in the forest night. Their forward-facing saucer eyes can't move in their sockets and take up half of their skull. Because of this, thanks to specially adapted vertebrae, Tarsiers have an owl-like ability to turn their heads 180 degrees in each direction. This gives them a very wide field of vision, keeping an eye out for both prey and predators. The tarsier has the biggest eyes in relation to their body size of any mammal. If human eyes were as big, they would be the size of grapefruits. Tarsiers also have excellent hearing, with thin, mobile ears that can be unfurled and retracted as needed. They can easily pick up the sounds of scurrying insects. Its gizmo's ability to detect and grab prey at night using its phenomenal senses that is the key to its success. But unusually, they don't have one ability that is common amongst nocturnal animals. When you look out into the darkness, it can be somewhat alarming to see eyes glowing back at you. The eerie twinkling is produced by nocturnal animals. Cats' eyes shine when caught in the glare of a torch or headlight. Targier's eyes don't. There is a layer of reflective cells at the back of the eye, behind the retina, known as the tapetum. This layer bounces photons of light back, giving the eye's sensory cells a second chance at absorbing the rays. Pigments in the retina affect the color of the reflected light. Not all nocturnal creatures have good eyesight. Bilbies are desert-dwelling marsupials from Central Australia. They avoid the heat of the day by being active at night. Also known as the rabbit-eared bandicoot, as the name suggests, the bilby has huge outer ears, all the better to hear with. They have a large pinnae, or external ear, that helps to funnel sound to the inner ear and gives the bilby its excellent sense of hearing. The bilby's big ears are hairless and thought to be useful for regulating body temperature. They are also flexible and can be rotated, held flat against the body, stuck out, or even folded in half. Bilbies aren't fussy when it comes to food. Helped by a long pointy nose with an excellent sense of smell, they forage for subterranean insects, bulbs, seeds, and fungi by digging through the soil with powerful limbs and foreclaws. It's thought they have such long ears so that when bilbies are digging deep, a portion of it remains above the ground to keep an ear out for predators. Perfectly adapted for arid conditions, they don't drink water but get all the fluids they need from food. By day, the bilby sleeps in deep, spiral burrows, which can be dug 2 meters into the ground. This protects them from the heat and daytime predators. In the arid Sonoran region of North America, another desert dweller, the kangaroo rat, goes about its nightly business eating grass seeds and stuffing them into its cheek pouches. This little hopper has specialized ears, but it's not the external part we see like the bilby, but the inside ear that's the key to their super sense hearing. They have an enlarged eardrum and huge air-filled chambers in the middle ear. This gives them acute sensitivity to sound, especially those at lower frequencies. This little rat may seem like it's had too much caffeine, but there's a good reason for its bizarre behavior. There's a hunter nearby with rat for dinner on its mind. Research has shown that the kangaroo rat's ears are adapted to nocturnal life, allowing them to hear the low-frequency sounds of predators, such as owls' wing beats or a rattlesnake's scales rubbing against the ground. The kangaroo rat senses danger and drums its feet on the ground, and these low-frequency sounds warn its offspring to be on alert. But it also sends a message to the snake that its presence has been detected and that the odds of catching a meal are low. The snake, meanwhile, will continue to wait for an opportune moment, and it uses every sense at its disposal to make sure it will eventually eat. After all, its life depends on it. Rattlesnakes, an iconic North American snake known for its characteristic rattle found at the tip of its tail. As night falls, a hungry rattler will move about looking for a spot to ambush prey. They use their heightened sense of smell to detect food by flicking their tongues in and out. This picks up scent particles and deposits them on the Jacobson's organ, a specialized chemical detecting structure located in the roof of the mouth. Rattlers are also known as pit vipers because they have heat-sensing organs located in pits near their eyes. This heat vision supersense is a useful tool for predators that need to hunt prey in total darkness. The pits allow them to see the heat signature of the prey, the warmth given off by an animal compared to its cooler surroundings, which provides a heat image. With an exceptional sense of smell and supersense heat-seeking vision, it's little wonder the rattlesnake is a formidable nocturnal hunter. Down under, the rattlesnake may have competition for the title of most effective nighttime killer. The cat-sized tiger quoll is a meat-loving marsupial. This voracious hunter eats possums, bandicoots, reptiles, and birds, tracking them down with its superior sense of smell. Like miniature bloodhounds, their movements are slow and deliberate. With nose to the ground, they follow the scent trails of their prey. Once food is detected, they are quick to attack. Razor-sharp canines deliver the killing bite. They're not fussy eaters, and if they sniff an easy meal like a dead wallaby laying around, they will happily chow down. But it's the quoll's sense of smell that may be even more important to their survival. It could actually save them from extinction. In the top end of Australia, the northern quoll population is in rapid decline. An invasion of toxic cane toads is the cause. Northern quolls have a taste for the amphibian, but once eaten, they soon succumb to the poison from the glands on the cane toad's shoulders. Researchers are putting them through quoll school by feeding them sausages made of cane toad legs, laced with a chemical to make the quolls feel sick. And it's working. The quolls are turned off their deadly diet. In terms of Antipodian nightmare animals, the quoll keeps good company. Along with its cat-like cousin, the Tasmanian devil is also a member of the family of flesh-eating marsupials, only much bigger. It is the largest of the carnivorous marsupials. As aggressive, brawling beasts, their ferocious behavior is legendary. During the day, the devil rests in caves or hollow logs, then comes out at night to find food. Like the quolls, they have a well-developed sense of smell, but are rather clumsy when it comes to actively pursuing prey. They prefer to scavenge on the dead. And it's at dinner time they will often encounter other devils. Jaw wrestling, teeth clashing, loud yowls and screams are all common in territory disputes. But a sense of touch is used here to minimize fighting. Tasmanian devils have long whiskers, not only in the usual whiskery places like the face, but also in clumps far back on the top of the head. Their long whiskers help them forage in the dark. They also help devils space themselves from each other when gathering together at a carcass. If devils' whiskers are not touching each other when they are feeding, they are safely outside of biting range. And with a bite force among the highest recorded for any species, that is something to avoid. With such a super sense resume, it's not the kind of creature you want to come across on an evening stroll. Following on the theme of Halloween frights, another creature that haunts our nightmares, the bat. Vampire movies have a lot to answer for, giving this little creature a bad reputation. But microbats, like the pipistrellus and Mexican free-tailed bats, eat insects, not blood. During the summer, Pipistrella females form maternity colonies where they give birth. These groups can number hundreds of individuals in what is known as a nursery roost. For 3 to 4 weeks, the baby bats are fed solely on their mother's milk. Feeding young costs energy, and research has shown that lactating pipistrelles make 2 foraging trips per night to feed their growing young. With a jerky, erratic flying style, they pursue insects which they eat on the wing. A single pipistrelle can consume up to 3,000 insects in one night. Its phenomenal prowess in aerial hunting is thanks to a special super sense, echolocation. Finding and catching small, quick-moving insects in the pitch black is not easy. Vision is limited in low light, so instead of using their eyes, microbats see with sound. They fire sound waves out into the darkness and listen to the echoes that come back. Using echolocation, the bat can determine where an insect is, how far away it is, and in what direction it is moving. It's a technique humans use to develop sonar navigation systems in the military, using expensive technology. The little bat, of course, just does what comes naturally with its super sense. The senses are the stars on Animal Super Senses, and this episode has been no exception. We've discovered animals use a range of sensory tools to cope with life in the darkness. Living the night shift doesn't stop nocturnal animals using every sensory tactic in the book to survive. So next time you're out there in the dark, watch out for things that go bump in the night. Join us next time on Super Senses to find out more incredible powers of animal perception.
Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever managed to stay on top of the food chain. Animal super senses. You won't believe what's possible.
What we see above the ground is only a small part of the natural world. A busy, complex web of life lies just beneath our feet. Fossorial animals are well adapted to life underground. They live in burrows, tunnels, and mounds, using the earth or whatever substrate they live in to build their homes, find their food and friends, and stay safe from enemies. In this episode of Animal Super Senses, we find out more about the animals that have their feet firmly planted on or under the ground, and find out how their senses are tuned to survive. For animals that live underground, adaptations for digging deep come with the territory. That includes strong limbs, claws to dig with, and a keen sense of touch. The wombat is the largest burrowing mammal, found in the temperate forest of southeastern Australia. They have stocky, powerful limbs, short necks, and broad, flattened skulls, perfect for pushing through the soil. Their forepaws are used for excavation. They can remove just about any obstacle with their incisors. To expand the sides and roof of a tunnel, wombats twist the upper body and perform barrel rolls. Their front end is backed up by an impenetrable posterior. Wombats have what is called a dermal shield on their rear, a plate of bone, muscle, and cartilage that can help defend their home from intruders. They can seal the entrance with their tough bums or squeeze under the invader and slam them against the tunnel roof. To avoid the heat of the day, this marsupial stays cool in its burrow. The wombat comes out at night to feed on grass and the roots and bulbs of plants. They are able to pick up the most tender shoots because of a split upper lip. And to cope with their fibrous diet, they have open-rooted teeth that are continuously growing, a feature unique among marsupials. A sense of touch is highly advanced in those that have a habit of living like a hobbit, and the wombat is no exception. Their cheeks, jaws, and wrists are covered in vibracées, whiskers that are specially designed for tactile sensing. Many animals that live the subterranean life have a need to be in close contact with their surroundings. It's a sense known as positive thigmotaxis. And although wombat senses haven't been studied too closely, it's likely they have this need to be in touch with tight places too. In the deserts of Central Australia, there are other creatures, many times smaller than the wombat, who also make their home underground. To shelter from the searing heat, rodents escape by burrowing deep into the cracks formed in the gibber, or stone-covered plains. Feeding mostly on seeds during the nighttime, they are perfectly adapted to the arid climate. They get all their fluids from their food. Gibber rodents live in small colonies, keeping in contact with burrow mates using a variety of calls, including squeals, whistles, chirps, and chatters. It's thought that their hearing is best at ultrasonic frequencies, perhaps an adaptation to avoid predators who may be listening above the ground. This rodent is not alone. Its subterranean shelter could be its undoing. Another creature is searching for sanctuary from the sun's heat and looking for a tasty meal. The inland taipan dwells in the cracks and crevices of the dry, rocky plains. And lucky for them, their favorite food lives in the same place. Cornering the rodent in its burrow, the taipan strikes with deadly poise. Injecting a lethal cocktail of paralyzing poisons. Its highly toxic venom is considered to be the most potent of any land snake in the world. The venom acts so quickly, the victim has little time to fight back. Food is scarce in the desert, and the snake must make use of every sense to find its prey. Smell tasting is the most important tool for sensing food. The forked tongue flicks rapidly, tasting the air for prey odors. This chemical information is then passed to the Jacobson's organ in the roof of the mouth, and then back to the brain for processing. Taipans can also detect their prey by sensing movement. They can hear by picking up vibrations along the ground. These travel through to the inner ear by means of a chain of bones in the lower jaw. Using its senses in this underground lair, the snake is a supremely adapted killer. Searching for prey certainly tests the sensory limits of animals. But when your food is minuscule and hidden, it really does need super senses to find them. The short-beaked echidna has a specialized diet. It only eats ants and termites found deep under mounds and logs. To get to the insect nibbles, the echidna uses its powerful, stout limbs to dig into the soil and rip open rotten wood. The front feet have 5 flattened claws, and the hind feet point backwards, helping the animal to push the soil away when burrowing. But it is the echidna's nose that is key to its success. Highly tactile, 8 centimeters long and rigid, this fair-sized proboscis helps this spiny anteater forage and poke around for food. The tongue can dart out to a length of 18 centimeters to catch its prey. And with the help of some very sticky saliva, with the consistency of molasses, ants and termites have little chance of escape. The snout is covered with tough, hairless skin containing glands and sensory receptors. Echidnas can detect prey by smell, but they also have an additional sense, found only in a handful of animals on the planet. With the tip of the snout, they are thought to have the ability to sense electricity. Until recently, the platypus and echidna were the only mammals known to use electroreception. Both are monotremes, egg-laying mammals, an ancient order of animals left over as a relic of evolution. The structures responsible for the electric sense in echidnas are sensory mucus glands. It's not fully understood how they use these, but tests have shown they can detect weak electric fields in water. As water is a good conductor of electricity, echidnas may be able to detect moving prey in moist soil. Even with a tough snout, echidnas generally avoid large biting ants for good reason. These nests are usually safe from anteaters. That's because there's a formidable fighter within. Australian bulldog ants are among the biggest and most primitive members of the ant world. They also pack a punch in their venomous sting. Easily recognizable by their huge jaws, bulldog ants use their sizable mandibles to carry food, construct nests, and defend their territory. They are active hunters and ferocious. If an intruder dares to venture near, the colony swarm out and attack within seconds, stinging them repeatedly with their venom. The ant chamber is underground and can extend several meters below the surface. It's here the queen lays her eggs, which hatch into fat, helpless larvae, lavishly tended to by workers. Most ants have poor eyesight, but a few have exceptional vision, and the bulldog ant is one of them. And they need their super sight to keep up with the insatiable appetites of their young siblings. Adults feed mainly on honeydew and nectar, but the larvae are carnivorous. The infants signal their hunger by raising their heads. Worker ants on dinner duty leave the nest and hunt alone, using their large eyes to find prey. Once they find a victim, they immobilize it with a deadly strike and carry it back to the nest. Workers bring dead beetles and bees into the chamber. The larvae attach and feed straight away. In their underground lair, it's important to be in constant contact with nestmates, both adults and young. The ants' antennae are special organs that help them detect chemicals and are also the touch sensor. They are used to identify friends from foe. Such an important sensory tool needs to be kept in top condition, and ants spend a great deal of time preening their antennae. An ant colony is a finely tuned machine with thousands of workers going about their jobs. And it's their super senses that keep this well-organized metropolis ticking along. Bulldog ants prove that being pocket-sized doesn't mean you're powerless. But there's a beast that ants would prefer not to run into: the antlion. It's not an ant, and definitely not a lion, And although it may not be as big as the king of the jungle, it's no less deadly. They are the larval form of a type of lacewing insect, and they are an ant's worst nightmare. Because antlions build death traps for their unsuspecting prey. They live buried in the sand, where the larvae dig funnel-shaped pitfalls with such efficient construction, it would put an architect to shame. The slope is steep enough to guide prey to their mouths, but shallow enough to avoid avalanches. The trap's sides are set at a perfect angle. When prey falls in, it has no way of getting out. Thanks to the unique wave propagation properties of sand, antlions can make use of the sand-borne vibrations to sense when their prey is near. These vibrations are picked up by sensory hairs on the head and antenna. It seems the antlion's senses are perfectly in tune with its sandlocked life. Deep in the Namib Desert of southern Africa is another predator who detects prey from vibrations carried through the sand. These are sit-and-wait huntsman spiders, and this parched earth is their home. The Namib huntsmen live in burrows that extend diagonally into the dunes. At night, they hunt insects, waiting patiently for the telltale signs of dinner as it crosses the spider's domain. Elongated hairs, called trichobothria, line the antenna-like pedipalps and legs. These sensory hairs are stimulated by air currents and low-frequency vibrations. The spider waits until the subtle tremblings of the sand signals its prey is nearby, then darts out to ambush the victim. During the day, dune spiders escape from the heat of the sun by staying underground, only coming out to repair or construct their lair. It's not easy to dig tunnels in the shifting sands, but the spider succeeds by lining the walls with silk. And it's at this point that the spider is at its most vulnerable. Their archenemy is a pompilid wasp, a parasite with a predilection for laying its eggs inside the spider's body, so the hatchlings have fresh and living meat to feed off. But all is not lost because this particular dune huntsman has a nifty escape plan. If its burrow happens to be on the side of a steep enough sand dune, it takes off and effectively invents the wheel. The spider rolls onto its side, tucks in its legs, and cartwheels down the slope, accelerating to a speed of more than 1 meter per second. That's the equivalent of a car traveling at 300 kilometers per hour. This species is not known as the wheel spider for nothing. Brush turkeys seem to have embraced the idea of modern man, because in this bird's world, It's the male that does the housework and looks after the kids. Male turkeys build large mounds comprised of decomposing vegetation, leaf litter, and soil. The suitor with the best maintained mound gets the girl. Females lay their eggs and then leave, and it's left to the fathers to look after the young. As the decomposing vegetation produces heat, it incubates the eggs. Keeping the right temperature is vital for their offspring's survival. So males check the warmth of the composting by inserting their heads in a hole. To keep a constant 33 degrees Celsius, the turkey removes or adds layers to the mound as needed. They can take the temperature by using highly acute heat sensors inside their upper bill. Without the brush turkey's bill thermometer, the embryos wouldn't develop. It's thanks to their super heat sense that a new generation is born. The senses are the stars on animal supersenses. We've learned digging deep doesn't stop animals from sensing their surroundings and making the most of what the Earth has to offer. Join us next time on Animal Supersenses to find out more incredible powers of animal perception.
Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever managed to stay on top of the food chain. Animal supersenses. You won't believe what's possible.
Throughout the natural world, individuals interact, and sending and receiving information is vital for survival. Animals use communication to attract mates, ward off predators, defend territory, or trick their prey. And of course, it's the senses that play the key role. Sight, smell, taste, touch, and hearing are all employed to send signals to others, in the hope actions speak louder than words. In this episode of Animal Supersenses, we find out more about the sensory powers used by animals to make messages loud and clear. Sun-baked Africa. Many animals find sanctuary from the heat in rivers and lakes. To keep cool, hippos spend much of their day wallowing in water. Even with their bodies submerged, the hippo can still see, hear, and smell what's going on around it. Their epidermis is thin, with no sweat glands. But they do secrete a red fluid, giving rise to the myth that hippos sweat blood. This secretion contains a sunscreen, an antiseptic, and moistens delicate skin. Large, slow, and rotund, these amphibious giants seem gentle and rather sleepy. yawning is a major pastime. But looks are deceiving. A large hippo guards his harem of females from sneaky males. If provoked, he will show who is boss. At 2,700 kilos, with formidable canines, the alpha sends a clear message to would-be Romeos. That's no sleepy yawn. It's a threat posture. Their 50-centimeter-long teeth can do some serious damage. Even with the hippo's poor eyesight, having a huge gape should get the point across. But just in case the visual threat is ignored, hippos send another warning. This time, scent is used in a rather unique way. Hippos have a great sense of smell, a fact not lost in domain disputes. As the hippo goes to the toilet, it vigorously wags its tail, spreading poop far and wide. Dung spraying is the hippo's way of marking its territory. Breeding males fling feces at the competition in hope that these smelly encounters will decide the winner without resorting to a fight. In the savanna of East Africa is another social species. Baboons live in troops of related females, offsprings of various ages, and several adult males. Each individual has a rank with a dominant in charge. They get the best resources first, including access to the ladies. But life at the top for the troop leader is not all fun and games. Every day, there are pretenders to the throne looking for mating rights. Young, virile males transfer from other groups to find a mate. These yawning threat postures send a strong visual message, exaggerating the length of the canines. But there are less aggressive ways of keeping your rank. Grooming is used to make friends and influence others. It's a communication tool that builds relationships and maintains strong bonds. This social sense of touch helps keep harmony in the group. A world away on a different continent, things are heating up on a California beach. These beach bums are northern elephant seals. It's late November, and the breeding season has started. Mature bulls have begun to arrive with one thing on their mind. The males will fight to determine who will be dominant. The winner's prize is a harem of blubber babes. Rather ungainly on land, these tubs of fat with pendulous noses can still pack a punch. In the elephant seal world, size does matter. The nose of a bull elephant seal starts to grow at puberty and continues to grow with age. It can reach 2 feet in length. Fights between males can get bloody and be surprisingly energetic. A testosterone-fueled fight has contenders rear up and slam their bodies against each other. The scars of past contests are clear to see on some bulls. But efforts are made to avoid armed combat. Throwing back their heads to show off their enormous proboscis, the message is clear, a visual signal to intimidate challengers. And the nose has another function to back up the menacing sight. It's a sound chamber to amplify bellows. The roar serves to identify individuals and assess their size. The bigger the nose, the bigger the bellow. The alpha male, also known as the beachmaster, roars his superiority. Mating season on the beach can be a noisy affair. Sight and sound are used to communicate dominance in the elephant seal's world. Thanks to the senses, conflicts are usually settled without a deadly conclusion. Another animal, where males flex their physical might to attract the opposite sex, lives down under. Twice the size of females, and with bulging biceps, males show off in the bushland gym. The gray kangaroo lives in semi-nomadic mobs. Ranging throughout Australia, they prefer open grassland with areas of bush for daytime shelter. At dawn and dusk, they come out to feed, grazing on a wide variety of grasses. Powerful back legs help them to travel at speeds of up to 65 kilometers per hour with minimal effort. During breeding season, males compete for females. Young bucks test their strength with each other by sparring. This ritualized fighting prepares them for adult life. In fact, the social life of a mob is akin to a barroom brawl, with constant pushing, grabbing and shoving, even while feeding. This tactile behavior serves to communicate their status in the mob. But the real action is reserved for the adults. It starts off with an aggressive grass pulling, followed by the agitator rubbing their chests on the ground. Kangaroos have an excellent sense of smell. Spreading the testosterone-laced odor is a way to threaten their rivals. Scent marking is an important form of communication in marsupials. Studies have shown that social status could affect odor composition and act as a chemical fingerprint. Muscle-bound males enter wrestling and kickboxing contests. They lock arms and try to push each other over. The meter-long tail is used for support when the back legs are lifted off the ground to kick opponents. It is a dominant male that gets to mate the most. Physical displays matter in the kangaroo world, not just to intimidate opponents, but also to woo the ladies. Lounging males of breeding age have been found to strike a pose to show off their bulky biceps. It's thought to be an effective strategy. Research has shown that males with big muscles are sexually selected for. In other words, female kangaroos find the hunkiest males sexy. Koalas sleep. A lot. In fact, for 20 hours a day. That's all they do. Apart from the occasional itch that needs to be scratched, but even then, they don't wake up. Their strict diet of eucalyptus provides little nourishment and they need to conserve energy. A very slow metabolic rate allows koalas to digest their food over a long period of time to make sure as much nutrition is extracted as possible. Waking hours are spent chewing the fibrous leaves, and getting enough nutrients is even more important if you are eating for two. Joeys are born after 35 days of gestation. The tiny baby looks like a jelly bean at only 2 centimeters long. It's hairless, blind, and has no ears. But it makes its own way from the mother's birth canal to her pouch. Relying on its well-developed sense of smell and touch, to navigate to a teat. The joey stays with its mom for a year, during which mothers and babies make soft clicking noises and gentle humming sounds to one another. Sensory communication strengthens bonds between mother and young. A life of eating and sleeping sounds idyllic, and this tree hugger seems gentle, placid, and for all the world like a cuddly bear. But when the breeding season arrives in August, there's another much more active and noisy side to koala life. The koala's keen sense of hearing is put to good use in the eucalypt forest. Males issue sounds with a mixture of grunting, burping bellows. The noise is 20 times lower in pitch than the koala should be able to produce, a fact that has baffled researchers. But recent studies have found the answer. Koalas have two sets of vocal cords, unlike any other land mammal. The deep resonating calls of male koalas can penetrate far across the forest, advertising his social and physical position to females. Koalas are mostly solitary and avoid interactions where possible. Male koalas have home ranges that stretch over 4 acres. Some of these territories may overlap. A mature male has a gland on his chest that secretes a dark, sticky substance. He rubs the odor on trees in the overlapping areas. In this way, koalas use the sense of smell to communicate their presence to rival males by scent marking their boundaries. When it comes to mating rituals and courtship, birds can outdo mammals by sheer showmanship. The avian world has all manner of visual and vocal displays to attract attention and impress. Lyrebirds shake their tail feathers like a Las Vegas showgirl. Mannequins moonwalk like Michael Jackson. Prairie chickens use big boom bass that can be heard over a kilometer away. Brolga cranes jump, dance, and pirouette like prima ballerinas. And Magellanic penguins bill tap and flipper pat like Bavarian slap dancers. The sooty tern is another avian groover. Noisy and gregarious at breeding sites, they form large communities on rocky islands. The incessant calls of the colony have given the bird its name, wide awake. Unlike most terns, they don't dive, but pluck fish from surface waters. At the onset of the breeding season, sooty terns congregate in dense aerial swirls offshore, gradually getting closer to the nesting ground. Courting pairs engage in high flights. They ascend to great heights, then glide rapidly down to sea level. Once the terns settle on the ground, they begin to display. With thousands of pairs in close proximity, the honeymoon couple need to stand out from the crowd to get to know their new partner and form a bond. Prior to mating, both mates circle around each other with dropped wings and heads tilted. Sooty terns are monogamous, and this visual display serves to form a strong relationship, necessary to rear young over the coming weeks. Once the pair is formed and eggs are laid, Both parents take turns incubating the eggs in shifts. When the chick hatches, foraging duties are also shared and sound sense plays a part. Adults call from the air as they come back to feed their chicks. The chick recognizes its parents' voices and calls back. They continue calling until the chick walks out to meet them, and the family share a fish supper. The satin bowerbird is not particularly flashy in the looks department. But it does have a unique way of getting attention. What it lacks in colorful plumage, it makes up for by kleptomania, stealing objects that it considers to be beautiful and worthy of display. This bird weaves a bower with thin twigs in an area to present its treasure for public viewing. The bowerbird is hoping to catch the eye of a passing female. It's particularly fond of blue objects. Different species have different color preferences, and researchers are trying to find out why. One theory is that bowerbirds choose the pigment that best complements their own coloring. The hard-working house husband spends a great deal of time arranging and rearranging his collection. He's meticulous at maintaining his design. When a big bird, like a brush turkey, comes wandering in, trampling his interior decorating, the poor male has to start again. But finally, it seems a female has taken interest. She inspects the bower and its contents. The bower and the blue treasure are only an enticement to step into the male's bachelor pad. The next stage of the courtship is the dance. The male leaps into action with a ritualized display of strutting and quivering, all the while carrying one of the bower decorations in his bill. To add to the assault on the female's visual senses, the male accompanies his routine with a variety of mechanical-sounding calls. If impressed, the female stays in the love shack for mating. Then she will leave to begin nesting duties on her own, while the male readies himself for courting new girlfriends. Communicating accurate information is important if you want to get the girl. But there are animals that send out messages which are far from the truth. Some predators deceive their prey to make capture easier. The alligator snapping turtle sits on the bottom of a pond waiting. He eats gambusia fish, which feed on mosquito larvae. Weighing up to 90 kilos, this reptile is one of the largest freshwater turtles in the world. The secretive sluggish creature spends most of the daylight hours hiding. Moving fast isn't in his repertoire. The turtle doesn't seem capable of catching swift-moving fish like the gambusia, but it has a cunning strategy. It lies in wait with jaws wide open. On the bottom of the mouth is a worm-like lure, which it wriggles to entice unwary prey. The powerful, sharp-edged jaws are capable of severing a finger, and the fish stands little chance of escaping. This is predator-to-prey communication, and visual trickery is the name of the game. But the title of Master Trickster should go to this creature. Dangerous and cunning, the Portia spider is a master of deception. Portias are a genus of jumping spider. Its favored food is other arachnids, like this one, a green water spider, called a hygropoda, which produces mat-like webs on leaf surfaces. The non-sticky silk doesn't snag prey as such. The web serves more as an arena for the fast-acting hunter to capture its dinner. The slightest movement is a critical attack cue. With stabbing fangs, hygropoda is a lethal adversary for a predator. But the jumping spider is not deterred. Using a remarkable hunting tactic, it exploits the water spider's sensitive detectors. The hunter slowly approaches the web of its prey. Moving its legs along the web, the Portia plucks the silken strands as it goes. It's not just testing for movement, but delicately strumming the threads to arouse the web owner's curiosity. With stealth as a weapon, the jumping spider is mimicking its victim's prey. This unique cryptic stalking is a remarkable strategy. But that's not all. Portia spiders are astounding scientists with their range of hunting behaviors. Their strategies alter depending on the species of prey in question. These redback spiderlings are defenseless against the Portia's cunning. They can improvise their tactics in unfamiliar situations and remember the technique. Researchers don't understand how a creature with such a small brain can seem so intelligent. But what is plain to see is the Portia spider uses the sense of touch to deceive its prey. The senses are the stars on animal supersenses. In this show, we found they are vital to animal communication. Visual displays depend on sight. Vocal performances rely on hearing. And scent trails trust in the sense of smell to deliver a message. Without senses, animals couldn't communicate. They would be isolated and struggle to survive. Senses truly are sensational, as we've seen. Find out more amazing powers of animal perception next time on Animal Supersenses.
Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever manage to stay on top of the food chain. Animal supersenses. You won't believe what's possible.
Animal Supersenses has taken us on an extraordinary tour of the sensory world of animals, showing us how many species have remarkable powers of perception. And every sense is employed to survive in a hostile world. The bear, with a sense of smell 7 times better than a bloodhound. The chameleon, with 360-degree vision. The elephant, hearing infrasound. With super senses like these, human abilities are pretty poor in comparison. In this episode, we revisit the most amazing super senses of animals. To become the supreme predator of the African savanna, the lion uses sniper's sight as a tool to kill. During daylight hours, their eyesight is said to be about level with ours. But at night, they shift gears. Lions are believed to see 8 times better than we do in the dark. A lion's eye is designed to pick up the faintest light. When night falls, the available light comes from the moon and stars. It makes the lion a formidable killer after dark. The clue to the lion's superior night vision lies inside the eye. The retina is covered in tightly packed light-sensitive cells, many more than humans have. But that's not all. They have what is known as tapetum, a reflective layer of cells at the back of the eye. It's what we see when we point a flashlight into the dark, and eerie eyes shine back. The tapetum reflects visible light back through the eye, giving the photoreceptors a second chance to absorb light rays. Thanks to the lion's super sense vision, they can hunt in the cool of the evening and save energy during the daytime heat. The lion has become the master of all its surveys. Another of Africa's big five, the elephant. This giant shares the savanna with the lion. Both are social animals. The African elephant lives in family groups of closely related females and young, led by a matriarch. Males wander on their own. When you live in the savanna, having the power to communicate over distance is important. It maintains family bonds and detects outsiders. It sends out a message broadcasting who you are, where you are, and if you are friend or foe. But it's a world that humans can't hear. Most of the sounds that elephants make are transmitted at lower frequencies known as infrasound, below the level of human hearing. These low frequencies travel great distances. As a result, elephants can eavesdrop over a huge area. They are known to make more long-distance calls after hours, namely at dusk when it's cooler and sound can travel further. It seems that the elephant's senses are perfectly adapted to its environment and essential for its survival. A female needs to signal to wandering males that she is ready to mate, but a breeding bull could be many kilometers away. Sending out a mating call that can extend over a savanna-sized range improves her chances of finding the biggest and strongest male. And it's the trunk call that no bull elephant wants to miss. Sight and sound are good for long-distance perception. But if you want to get up close and personal, the sense of touch is going to be your best bet. Touch plays an important role in the life of a kangaroo mob. Mutual grooming is a practical way for this social animal to form close bonds. And there are few bonds in the wild stronger than a mother kangaroo and her baby Joey. Young roos test their strength with peers by pushing, grabbing, and shoving each other. But the real action is reserved for the adults when touch becomes territorial. And muscle-bound males show off in a bushland gym. A tactile toolkit matters in the kangaroo world, as the winning wrestler gets to mate the most. One of the greatest noses on Earth belongs to this creature. Perhaps no other animal has a keener sense of smell. Smell helps the bear to find food. They can detect a meal several kilometers away. The sense of smell also plays an important role in bear communication, helping them to locate mates and to recognize their young. Even though a bear's brain is only about a third the size of a human's, the area of its brain which manages smell is at least 5 times larger. The surface area inside their noses is thought to be 100 times greater than a human's. Making their sense of smell 7 times better than a bloodhound's. It can easily smell traces of food left on clothes and in tents. So, if you're camping out and there's a sniffing sound, you may have a bear at your picnic. Some animals seem to have superhuman senses. Take, for example, the monarch butterfly, with its superior sense of direction. They spend their summer months in the eastern part of North America, before flying south to a single mountainous spot in Mexico. A journey of up to 5,000 kilometers. How do they navigate their way? It's a question that's intrigued scientists for years. Now, experts think they know the answer. The monarch butterfly detects the Earth's magnetic field. An internal compass, located in the antennae, contains light-dependent magnetosensors. The butterflies that have flown south enter a period of inactivity as they overwinter in Mexico. The warm, lengthening days of March signal them to be active again. They become ready to mate and lay eggs as they move northward. Their eggs mark the start of another annual life cycle. And a new generation uses the internal compass to make its epic journey north for the spring. The monarch's phenomenal abilities in the air may be matched by the shark's prowess underwater. Animals seem to sense changes in the environment that completely escape human perception. In 2001, a team of researchers had been tracking the movements of a population of black-tip sharks off the coast of Florida. The sharks were residents in the bay for 6 to 8 months during the summer and didn't leave the area until migration time, and definitely not in large numbers. Tropical storm Gabrielle made landfall in central Florida during their research. When the team returned to check their equipment, they reviewed the movements of the tagged sharks to find an amazing result. Not only did all the tagged sharks leave, but they had left some 7 hours before the tropical storm hit the coast. Scientists examined the data to try to find out what on earth was going on. They found the sharks swam to deeper waters, just around the time when the air pressure started to drop prior to the storm's approach. It seems the sharks responded to the decrease in pressure and got out of town before the storm hit. Animals that live life on the wing have to make the most of what the aerial realm has to offer. Given the vast openness of the sky, their senses have adapted to cope. Being small doesn't matter. The dainty dragonfly is one of the most brutal and effective predators in the animal kingdom, thanks to its superior sight. They have multifaceted or compound eyes, and along with bees, have the largest eyes of any insect. They see the world in a mosaic. But that's not all. Dragonflies have 5 opsins, or light-sensitive proteins. Humans only have 3, for seeing red, green, and blue light. This allows dragonflies to see colors beyond human abilities. And it's these opsins' unique placement in the eye of the dragonfly that helps them to hunt. The upward-facing part of the compound eye only has blue and UV receptors. It may help hunting dragonflies as the sky appears to be very bright, giving a clear background against which small, fast-moving prey can be more easily detected. Dragonflies have fighter-pilot control and rarely miss their target. They can fly backwards, change direction in midair, and hover for up to a minute. Because of this, their prey stands little chance. And it's their super sense eyes that make the dragonfly a formidable aerial hunter. Another aerial predator uses a revolutionary technique to catch its dinner. They also have to grab small, quick-moving insects during flight, but they have an additional challenge. They have to find their food in the dark. Microbats spend their day in roost sites. This is where they mate, raise their young, and socialize. During the summer, females gather together in their hundreds in what is known as a maternity roost, where they give birth to a single baby called a pup. For around 4 weeks, the baby bats are fed solely on their mother's milk, until they are old enough to fly. This period costs a lot in terms of energy for the mother. So they enter a state of torpor during the day to reduce their body temperature and metabolic rate. At sunset, they emerge from their roost to pursue insects and stock up on lost energy. A bat can consume up to 3,000 insects in one night. Their success in aerial hunting is thanks to a special super sense, echolocation. Instead of using their eyes, microbats see with sound. They fire sound waves out into the darkness and listen to the echoes that bounce back. Using echolocation, the bat can determine where the insect is, how far away it is, and what direction it is moving. It's a technique humans have used to develop sonar navigation systems in the military, using large equipment and expensive technology. The little bat, of course, just does what comes naturally. Thanks to echolocation, living the night shift doesn't stop this bat using its sense to survive. Finding food hidden underground has similar challenges to hunting prey in the dark. In both cases, the sense of sight is tested to its limit, and other sensory tools are needed. The short-beaked echidna has a specialized diet. It only eats ants and termites hidden deep in the earth. It uses its powerful, stout limbs to dig into soil and rip open rotting wood. But it's the echidna's nose that is key to its success. Echidnas can detect prey by smell, but they also have a unique sense found only in a handful of animals on the planet. With the tip of its snout, they are thought to sense electricity. Until recently, the platypus and echidna were the only mammals known to use this electroreception. The structures responsible for this electric sense in echidnas are sensory mucus glands. It's not fully understood how they use these, but tests have shown they can detect weak electric fields in water. As water is a good conductor of electricity, echidnas may be able to detect moving prey in moist soil. Sensing changes in the environment is vitally important to animals. Their lives depend on it. If winter is coming, they have to adapt. Some animals register seasonal change by refashioning their winter wardrobes. During the short polar summer, the Arctic fox's fur is brown. But as winter sets in, the fur becomes thicker and turns white. But exactly what is at work to help animals keep in sync with the seasons? Deep inside the brain of many animals is the pineal gland. It produces the hormone melatonin. The pineal gland can measure the length of day versus night. It receives this information via the eyes. Melatonin levels are low during daylight and increase to a peak at dark. As winter approaches, the hours of daylight shorten and melatonin increases. The hormonal surge cues the Arctic fox's sense of timing to change its coat color. In Animal Supersenses, we've seen how the sensory world of animals is astonishing, varied, and in many cases, superior to that of human abilities. Senses are vital to animals. Without them, they would be cut off from the world, unable to see, smell, hear, taste, and touch their environment. Animals' supersenses are their key to survival.